Hello viewers, welcome back to my channel. This is Science Class Online, and here we learn difficult topics in chemistry, basically the foundation topics in chemistry, and we also learn other topics for external examination and for final examination as well. So here today we are considering formation of ions, which is cations. You might have come across these terms, cations, anions, even ions. I've made a video on ions, how ions are formed. But here I want to be specific how cations are formed. So if you are yet to subscribe to my channel and you would like to follow my teachings, please do so by pressing the subscribe button, press the like button, and then the notification bell to get alerted anytime I drop new videos, and also share my videos to as many as possible who are in need of this. Now, ions are formed whenever an element gives out electrons or gain electron. So, out of the first 20 elements, which I've made a video on, if you are yet to learn the first 20 elements as well, check the link below. You will see first 20 elements and how to write their symbols too. So out of the first 20 elements, I've coined out some of the elements that usually give out the electrons. I said ions are formed whenever element gives out or gain electrons, and there are basically two types, although we have another type which is the radical. So, but in this case now they involve single elements, anions and cations. Now the ones that gives out the electrons are called cations, while the ones that gains electrons are called anions. But here we are working on cations. So lithium, a very good example of a cation, is an element that usually give out, and the atomic number of lithium is 3. So normally we arrange electrons in shells. If the atomic number is 3, it means it has 3 electrons as well. So the first shell takes 2, the second shell takes the last one. Normally the second shell, third shell, fourth shell, fifth shell supposed to be taking 8, filled up to 8. But the second shell in this case using 3. The first shell takes 2, the last one electron falls on the second shell, which is 1. So in this case now, lithium is in need of 7 more. It needs to gain 7, but it's very, very difficult to gain 7. Rather, it's easier giving out 2. So such element gives out electrons easily. They become positively charged and they become ions. They change from atoms and then they become ions. Then their number of electrons reduces. Though the atomic number is the same, atomic number is the number of proton. So the atomic number is the same, the number of proton the same, the number of electrons reduces in cations. So in this case, even the shell number drops. So lithium becomes positively charged. With the number of electrons given out, we write it on it as 1. The next element is beryllium, which has atomic number of 4. Arranging this, the first shell takes 2, the second shell takes the remaining 2. So it means that this second shell is in need of 6 more electrons, but it's very difficult to gain 6. Rather, it's easier giving out 2. So such element becomes positively charged. And take note, those elements that gives out the electrons easily to become positively charged are metals. Most of them are metals. So metals are electron donor, so to say. So their number of atomic number is still intact, 4. The proton number is also 4 because the atomic number is the number of proton. But the number of electron reduces to 2. And the shell also drops to 2 because they will end up giving out these 2 outside electron. That's a valence electron, the electron and the outermost shell. It will be given out and they become positively charged. Why are they becoming positively charged? Because they are losing an electron that is negative. If an element gains, it becomes negatively charged by gaining electron, because electron itself is negative. So when they add it to themselves, they become negative. But in this case, we are dealing with positively charged ions. So the next one is boron, which has atomic number of 5. The first shell takes 2. The next shell takes the last 3. This is also in need of 5 more to make it 8. So as to attain a noble structure, noble gas structure. You know, noble gases, they have their shells completely filled, like helium number 2. 2 shells, 2 on the first shell, which is complete, is a noble gas. Neon is another noble gas. It has atomic number of 10. The first shell takes 2. The last shell takes 8. Complete. So anytime an element tries to give out electron or gain electron to themselves, they are trying to attain the nearest noble gas structure. They want to be like the noble gases, to be complete, to be stable. Now, in this case, now boron we end up losing 3 because cannot gain 5 more. It's difficult gaining 5, but easier giving out 3. So it becomes boron with oxidation number of 3. Don't forget the valence electron is also 3. The oxidation number is 3. But the valency here, you will just remove the sign. That is the valency. Now, so sodium is the atomic number of sodium is 11. When you arrange this, you have 2. You have 8, making it 10. Then the last shell takes 1. Sodium here has 1 valence electron. The oxidation number will also be 1. Why? Because it will end up giving out the only one, instead of gaining 7 more to attain the nearest noble gas structure. So it becomes Na plus 1. The valency is also 1. You remove the sign from your oxidation number, you get valency. Now, don't forget when element gives out, they become positively charged. The next one is magnesium with an atomic number of 12. So we have 2, 8, and the last shell takes 2. So it ends up giving out 2 to become Mg raised to power 2. So in this case now, there's a difference between sodium atom and sodium ion. There's a difference between magnesium atom and magnesium ion. Magnesium ion now has atomic number of 10 because they will end up losing the last 2 here, and their shell number will drop to 2. They will end up, because they cannot gain 6 to make them complete. So the last one here is aluminium. We have atomic number is 13. So we have 2 and 8. Then the last shell takes 3 as well. This will end up giving out the 3 valence electron because it cannot gain 5 more. So you end up having aluminium ion with, after giving out, they become ion, and they are giving out 3. So they become positively charged, and they have electrons of 10, not 13. So, but the atomic number or proton number is still intact, which is 13. So, if you don't forget to subscribe to my video, to watch out on my videos on formation of anions, which is a negative aspect, and also get more interesting topic. Thank you.